Start, get set, go! Let us embrace what is in front of us. You guys are fortunate you're here in class today, because if you're watching the video, you're not going to probably understand it as well. So, we start with the basic. And the most important thing you can do today is to be curious. And it starts with the rate of snow accumulation during time 0 to 8 is given by this differential function R of t, where R of t is measured in inches per hour and t is measured in hours. Selected values R of t are shown in the table above. At time equals 0, there is currently 2 inches of snow on the ground. Can anybody tell me what the heck does 1-3 even mean? After 1 hour, 3 inches have accumulated. True or false? False. At time 1 hour, it is snowing at a rate of 3 inches per hour. That's what we know. So taking that information, pause and talk and decide, is there a time from 0 to 8 when the snow is accumulating at a rate of 2 inches per hour? Talk. Go. Talk. Decide. Okay, and stop. Yes or no? Why? Why does it have to snow at a rate of 2? Right, so in order to get from 1 to 3, it has to cross over 2. Everybody see that? Do you remember the theorem that we talked about that said in order to go from 1 to 3, you have to cross over 2? So then IBT, value theorem, intermediate value theorem, yay! Give Shelley a round of applause, go Shelley! All right, now, technically, in this situation, the answer would be no. And the reason why is because it doesn't say that it's continuous. But we're going to assume that snow falls at it never it doesn't stop and then just all of a sudden just start at a rate of 3. We would say that it has to go, like if you're gonna stop and you gotta go to 3, you gotta cross over everything in between. That would seem logical, and they would specify that on the test. So something I've left out is this, and don't get confused when they say it. They'll say that R of t is continuous and differentiable. That means that in order to get from 1 to 3, you have to cross over 2. So in this situation, we will say yes. And so it says justify your answer. And in order to justify your answer, we say, because too cold. Fields are wet.
It's never too cold. It's always too wet.
Too wet. Because R of 1 or R of 0 is equal to 1. And R of 1 is equal to 3. So because R of 0 is 1, or R of 0 is 1 and R of 1 is 3, the IVT, the intermediate value theorem, guarantees R of t is equal to 2.
You'd have to write IVT.
Yes, you must invoke the IVT. And you don't have to say the intermediate value theorem. You can just say IVT and then say, we know what you're talking about. Super important part, okay?
Forget what it's called.
Yep, you won't get the point. You will not get the justify. So this would be worth 1 point on the free response right here. And you would have to get the correct answer and the IVT justification. If you don't do it, it's wrong, okay? All right, for the next one, it says, is there a time from time equals 0 to time equals 6 where the derivative of R is 1/2. So I changed that from 8 to 6. So you're looking from here to here. Is there a time where the derivative of R must be 1/2? I'm sorry. Well, we're going to change that to, I made a mistake here. Okay. Where it must be 1/3. Okay. 1/3. You can talk with your peers and decide, does that have to be true or not? Go. All right. Anybody, yes or no? Yes. And the reason why is this, okay? If you take R, notice R prime is the derivative, correct? So that's the rate of change. Well, if we look at the average rate of change, say R of 6 minus R of 0, and divide that by 6 minus 0. Let's see what we get. What is r of 6? 3 minus 1 divided by 6, or 2 over 6, which is 1/3. Do you remember the thing that we did, since justify your answer, remember the thing that we did where we took something and divided by something? Remember what that was called? Mean value theorem. Thank you. So because of that, the mean value theorem guarantees r prime of t is equal to 1/3. Good? Yep, MVT. Yep, sorry. Yep. And notice how we gave you 0 to 6, so you just look 0 to 6. It would maybe be a case where you need to look from like 1 to 3 or 0 to 3. You might not be able to pair them up exactly. You might have to look for a spot in the interval where that's the rate of change. Yeah, it won't always just be the beginning and the end. You might end up having to look at the middle to come up with 1/3, or maybe you might have to dice it up a little bit. But usually they kind of give you that. They give you that. So all right. Estimate r prime of t over the interval 0 to 8. So estimate, and this is the derivative, okay? So we estimate the derivative by simply finding the slope. So we do r of 8 minus r of 0 divided by 8 minus 0. And what is r of 8? 1/4 minus 1 divided by 8. What is 1/4 minus 1? So we get -3/4 divided by 8. -3 over 32, and we should put a label. Okay, what is the label for our rate? Inches per hour. So if it's the derivative of the rate, it's inches per hour squared. So this is inches per hour squared. Good. Use trapezoidal sum with 4 subintervals to approximate the total accumulation of snow from 0 to 8. This is an extremely popular question on the AP exam. You're going to get this kind of question, and we'll start drawing our trapezoids. So I'm going to have 4 of them. Can I draw them up here? Because I can't see the whole screen. You guys can. So we're going to draw up just 4 trapezoids. Kind of did this a little bit the other day. You guys did a really good job with it because you guys are smart. I just got done talking about you guys a little while ago. Talk about how great the class of 2022 is. For all of you who are listening to the video right now, you just missed a great discussion, okay? You're all invited to my house, but not till you graduate. Okay, so let's do the subintervals, okay? Talk to you guys about being a great class. You can do this. We've got this. I need this width right here. What is this? 1, and then I've got 2, 3, and 2. And then I need the heights.
Where would you get all those numbers?
Yeah, exactly. Somebody tell Morgan where we got them.
0, 1, 3.
Yeah, 0 to 1 is 1, 1 to 3 is 2, 3 to 6 is 3. See that? And then what are the heights going to be? Yeah, 3 and 1, and 3 and 4, or 4 and 3.
What?
4 and 3.
So now where are you getting those numbers?
Right here. These are the heights for the first one. These are the heights for the second one. These are the heights for the third one. I got 3 and 1/4. So do you remember the calculation for the area of a trapezoid? 1/2 times that base thing plus then the sum of those 2 heights, right? So let's do that, okay? So I got 1/2 times, you guys got to help me because I can't see it. 1 times what? Is it 3 plus 1?
Yeah.
3 plus 1. And then plus, it'll be 1/2 times, is it 2? Times the sum of 4 plus 3. And it'll be plus 1/2 times 3 times the sum of 3 plus 4 plus 1/2 times 1, because the width was 1.
Yeah. So why are we times it by 1/2?
Because that's the formula for area of a trapezoid.
Oh, wait, it was 2. I got it.
It was 2, thank you, times 3 plus 1/4.
3 plus.
Okay, so let's figure those out. 3 plus 1 is 4, times 1/2 is 2. 1/2 of 2 is 1, and I'll get 7. 3 plus 4 is 7, times 3 is 21, so 21 over 2. And then 1/2 times 2, again, is 1, and then 3 plus 1/4, that'll be like 13/4. Right? So, this is a non-calculator problem. I'll write them all in terms of fourths. So I would have 8/4 plus 28/4 plus 42/4 plus 13/4. And so the 28 and the 42, that makes 70, 83, 91/4. 90/4 what? 91/4 what? What the heck did we just do? Inches. Yeah, that's what's accumulated. True or false? That's how much snow is currently on the ground. False. Why? Because we started with how much? At time equals 0, there's 2 inches of snow on the ground. That leads us into our next question. Use a left-hand sum with 3 subintervals to approximate the amount of snow on the ground at time equals 6. This is easier, okay? So the amount of snow on the ground, so it's going to be our start plus our displacement, right? See how this is similar to the kind of the motion question yesterday? If you can see that these are similar, that's going to help you on the test. So I take 2 plus the integral from 0 to 6 of r of t dt. That's what we're doing. It's just that we're given a table. So we can't figure this out exactly. There's going to be no antiderivative. There's going to be no calculator. It says in order to estimate this integral, we use a left-hand sum. So I take 2 plus, and we're going from 0 to 6, and it says left hand. So let's check this out. I've got 3 subintervals. So I'm going 1, 2, and 3. So what's the width of the first rectangle? 1, and what's the height? 1. Good. So 1 times 1 plus, what's the width of the second rectangle? 2, and what's the height? 3. Yep, the left-hand side. Good. So 2 times 3 plus, what's the width of the last rectangle that we're doing? And what's the height? 3 times 4. Okay, good. So I get 2 plus 1 plus 6 plus 10. So 2 is the start, and then I have 16, 17, 18, 19. So 19 inches of snow is currently what we think is on the ground. What? Because 3 times 4 is 10, Raiden. 21 inches of snow on the ground. You're not invited to the house. What's that? Yeah. It says use a right-hand sum with 4 subintervals to approximate the average rate at which snow is accumulating from time 0 to 8. Oh my goodness. You take 30 seconds and see if, don't use the right-hand sum, see if you can come up with an expression using like an integral to even figure out what the heck we're talking about. Talk with somebody near you. See if you can try to place the question in reference to what we talked. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. So the average rate. Are we given the rate function? So we're wondering the average of that. What do we do to calculate the average value of a function? Yeah. Yep, you guys had it. So what we would do is we would do 1 over 8 integral from 0 to 8 of r of t dt. And we would do a right-hand sum. Now, you guys know how to do right-hand sums, right? So can we just say that you would know what to do from this point? Okay, good. So let's flip it over. We'll do one more. Please make sure that you take out your calculator. Okay, this is probably the third or fourth most common type of question that you get for free response. This is what I call as arriving and departing kind of question. And this can be all sorts of scenarios. For example, we've seen ones where like rock is being brought into a plant and then it's being processed. So you see as it's being brought in and it's processed, that's arriving and departing. So in this situation, people arrive at a gym at a rate modeled by this, and then in people per hour, people also leave the gym at a constant rate of 3.2 people per hour. And at the beginning time, there's 50 people in the gym. Now, I'll be honest, I made up these functions on my own. They're not that great of functions because the number of people doesn't change too much in the gym. But we'll do our best. It says, how many people arrive? Not how many people are there, but how many people arrive in the gym during the first 4 hours. Any idea how we would try to calculate that? Yeah, integral 0 to 4 of my rate function. So I'm going to go to my calculator, because this is a calculator problem. I go into y equals, and I type in 3 e to the x. Note to self, come up with a, oh, it's e to the x sine of x. Ooh, I got to put all that in parentheses. Who makes these crazy functions? Mode, can make sure I'm in degrees. Note to self, make up a new equation next year. Zoom 6. Oh my goodness, look at this crazy function I've got there. So maybe it's not that bad. I don't see the top of the function. I am going to go into my window, and I'm going to increase my y maximum up to 40 and a tick mark every 10 just so maybe I can see it and get a better feel for what's happening here. Still can't see the top of it, can I? Oh yeah, now I can. Because I'm just going 0 to what time? 0 to 4, right? Yeah, so I'm going to second calculate, and I'm going to go from 0, and do number 7. I'm going to go from 0 to 4. And that will tell me the number of people that are arriving. Yep, number 7. 31.551. I need a label. People, yeah. How many people leave over the first 4 hours? How'd you get that? Yeah, there's 3.2 people leaving per hour, right? And actually, if you did the integral from 0 to 4 of 3.2 dt, notice what happens. What's the antiderivative of 3.2? 3.2t, right? And you're evaluating that 4 and 0. Can everybody see you just take 3.2 times 4? So that's the operation. So as Colin said, you get 12.8 people are leaving. Yeah, people are getting cut up here. Yep. Now, here's where it gets really interesting. It says, to the nearest person, how many people are there in the gym at time equals 2? Well, how would you try to figure out, don't give me numbers, give me like a general expression, like how would you figure out how many people are in the gym? You'd want to factor in the start plus, don't give me mathematical expressions, give me words. Start plus the number of people who arrived, right? Then what? Minus the people who departed, right? everybody on the same page there? We need the number of people who started, add the number of people who arrived, and subtract the number of people who departed, right? So let's do that. How many people started? 50 plus, how do we calculate the number of people who have arrived? Integral from 0 to 2 of r of t, and then just minus the departure, right? I could write that as one integral, so minus 3.2 dt. So you could take integrals and put them together as one as you're adding and subtracting. Everybody see that? So I want to figure out this integral of r of t minus 3.2. And so I'm going to go to my function, and I'm going to take this guy, and that's r of t. Now I'm going to subtract 3.2. And if I go into my calculate, do number 7, now I'm just going from 0 to 2. Maybe I don't have that bad of a function. It's kind of cool. Going from 0 to 2. So I get 50 plus 11.021. Or 61.021 people. Oh, the nearest person, 61 people. Sure. Okay, this is kind of a little bit more challenging question. So we're getting to those tougher questions. During the first 4 hours, when is the attendance at the gym increasing? Don't think about mathematical expressions. Just think about context of the problem, arriving, departing, stuff like that. Talk with a friend. How would you try to figure out when is the attendance going up and not going down? See if you can talk about what it is. Go. Okay. How about this? When the rate of arrival is greater than the rate of departure. That's when the attendance would be going up, right? Is everybody good with that? Does that make sense? See how I just came up with an expression to try to think about the problem. Now let's go to the math. What do we have that tells us the rate of arrival? R of t. Greater than, what do we have for the rate of departure? 3.2. So we're wondering when is R of t greater than 3.2? And there's actually a really easy way to calculate this. Let's just do when is R of t minus 3.2 greater than 0? When is R of t minus 3.2? When is it above the x-axis? Everybody see that? That's what we're trying to figure out. That's not too bad. So I think I actually have R of t minus 3.2. I think I have that plugged in my calculator, right? So if I just look at the graph, I'm looking, it looks like it dips below the x-axis here, doesn't it? So you remember what I do to calculate those spots where it crosses the x-axis? Yeah, second calculate, and we use the 0 option. We'll see if we remember, because this was kind of new yesterday. I go to my 0, and once I'm there, where do I go? To the left. Am I above or below the x-axis now? Above, press enter, and now I'll move to the right till I'm below, and it says 3.12. And then I want to calculate that other spot. So I'm going to calculate my 0, number 2. I'm going to go over to that spot over here. Whoop, wherever. It's right about there. It says move to the left. Am I above or below? Below. Press enter. Now make sure you move above to do your second part. Whoop, that went way off the screen. Press enter. And I get 6.293. Well, I forgot to go to 3 decimal places for the other one. My bad. And so that's what we set up. So remember, it was from time equals 0 to time equals 3.12. That's like one interval, right? 3.121. Everybody agree that that's the first spot where it's above the x-axis? So you could also write it like this. So we got 6.293, 6.293. So you could also write 0 less than t less than 3.121 and 6.293 less than t less than 8. Oh, it says during the first 4 hours, doesn't it? Okay, so we don't even need the second part, do we? We just need that first part. And that's sometimes what happens to me. I go through the problems and I forget like the time space that we're working and whatnot. Okay. Oh, right at 0? Okay. Oh, you think it starts there? Oh, does it really? Let's pretend like it doesn't. Did you get his point that it might start below the x-axis right away? Yeah. Yeah. Okay. So, all right. So I should have thought about that. Looks like we screwed that up. That's something you would have to consider. And then let's just talk the last one. Is the rate at which people are arriving in the gym increasing or decreasing at time equals 3? So let's look at the rate. What do we have as our rate function? This guy, right? We're wondering, is it on its way up or is it on its way down? Tell me, if something is on its way up, then we know what is what. The slope is positive, or the derivative is positive. So if it's increasing, the derivative will be, if it's decreasing, the derivative will be. So that's all we have to figure out. It says the rate at which people are arriving, so we're only wondering about r of t. So I'm going to go ahead and I'm going to delete this negative 3.2. And how do I figure out the derivative at time 3? So I can calculate number 6. And what do I type in for number 6? I type in 3. And you can even look at the graph 1, 2, 3. It looks like it's probably on its way down. And sure enough, so I say r prime of 3 is equal to negative 12.959. Thus, the rate of arrival is decreasing. Now, although this is a pretty good problem overall, I have to tell you right now that that question, it should have said, is the rate at which people arrive in gym increasing or decreasing at time equals 3, and it should have said justify your answer. Because they will never give you just a simple yes or no. They're going to say justify your answer to then give that point. So you want to show that you're considering the derivative, okay? And the last question, not a big fan of it right now. We'll just get confused by it. So you made it through 6 problems so far. Tomorrow I just want to finish up the last 2. And then you will really have made it through a really strong kind of introduction into reviewing for the AP exam. And there's going to come a time next week where you're going to start doing more trying on your own. And you're going to be like, oh, I've seen this kind of problem before. Mr. Gens did this one for us. Oh, I remember this. Oh, I haven't seen this at all before. I'm just going to have to try and see what I can do. So good work.